and welcome to another episode of Learn with Dr. G. That's me. Today, I'm really excited to continue on our space exploration journey as we discover how we can use code, data science, machine learning, Python, Visual Studio Code, and all of that to help us discover more about space. So stick around. So today we're going to be talking about how we can use machine learning and data to predict whether or not a rocket will launch or if the rocket launch will be delayed. This is part of a learning path that was created on Microsoft Learn, which you can find at aka.ms/launch delays with ML-11 here on the screen down below. And the goal of this learning path is really to take a real world problem, an out of this world problem, and try to apply code and data science principles in order to see how one might go about solving it. Now, I am not a NASA engineer or scientist. I don't do this for a living. We've definitely simplified the problem here just for the purposes of exploration, but I'm still really excited to go through it. We're actually not going to jump into the code today. I'm going to be doing a live stream where we code up this entire machine learning algorithm and actually try to predict whether or not a rocket will launch. If that live stream has already happened, you can watch it in the next video on this YouTube stream. And if it hasn't, well, then come back and come join us in the conversation during the live stream. But what I did want to talk about briefly today is some of the key factors to take into account when you are trying to design a technical solution to a complex problem. We're first going to jump into an introduction to rocket launches in general to try to get an idea of how complex this problem really is. Then we're going to talk a little bit about the data collection and manipulation phase of solving this problem. And at the end, we'll touch on how we can build a machine learning model that can accurately represent our problem and/or solution. So one thing that you may already know is that rocket launches are highly dependent on weather. That seems fairly obvious. Even an airplane is dependent on weather. But a question that I had was, if rocket launches are dependent on weather, why would we continuously launch rockets from, say, Florida, where the weather in terms of wind and rain and humidity and pressure is often varying and unpredictable, instead of, for example, launching out of San Diego, California, where the weather is pretty much the same all the time and it's not too hard to predict. What I learned throughout investigating this project, which happened to include being able to talk to some actual NASA scientists, was that Florida, in particular, where they actually launch from, is one of the closest locations between Earth and where we can break through the atmosphere. And it's obviously near a lot of ocean, so that in case anything goes wrong, our astronauts can safely deploy into the ocean and hopefully no one will get hurt. So this was one of the very first pieces of this really complex challenge that I hadn't thought of, and that you could use data to determine where an appropriate location might be. So I would encourage you, if you are excited about this topic and want to continue doing more, to maybe explore other areas of the globe and see where there aren't currently places to launch a rocket. Would there be a better place to launch a rocket that takes into account all of the information, such as access to everything that is needed to build and safely launch, access to an ocean or an area that'll make it safe to, drop things off into, or have the astronauts land near, and then also taking into account weather, which we're going to talk about in just a minute. I think it would be really neat if we could identify that my cousin's backyard in Alaska might even be a better place to launch, and I just think it's funny to think about launching a rocket from my cousin's place in Alaska. Another really important aspect to launching a rocket is going to be weather. And while we can't accurately predict the weather entirely, we can choose seasons or timeframes that we think will be the best chance at having good enough weather to have a safe and successful launch. However, there are some considerations that need to be taken into account the days leading into a rocket launch as well as the day of. We actually saw this in the summer of 2020, where the weather conditions the day of a rocket launch weren't optimal and they had to postpone the launch. What's really neat is that here in the US, we have an organization that helps us launch safely into space. And they've created this FAQ that talks a little bit about weather and the considerations we need to take into account. So a couple of icons here to take note of. These 6 icons represent 6 things that we need to take into account prior to launching a rocket to ensure the safety and success of the launch. For example, on a pretty clear, somewhat cloudy day, we always need to be taking into account the surface electrical field, the time of day, and the distance from the rocket to any kind of weather, any kind of pretty much anything. In particular, we're always worried about clouds because clouds is what help create lightning and therefore make our launches a little less safe. If there is, for example, actual lightning from clouds happening, there are some considerations we need to take into account. For example, the distance of the rocket from the cloud that is producing lightning or clouds, the time of day, and the surface electrical field. However, you can see that the shape of the cloud and therefore the type of cloud that is producing the lightning also has an impact on whether or not the rocket launch will be successful. For example, an attached anvil cloud that is producing lightning, we also need to be taking into consideration the temperature of the atmosphere and not just how far away we are. And we need to make sure that the trajectory of our rocket is away from that anvil cloud. There are actually a lot of considerations that we need to take into account. And our biggest goal when we're thinking about clouds is to avoid rocket-triggered lightning that happens as a result of the rocket launching in a place where there are clouds. That's just a very brief intro into how weather and specifically clouds can affect a rocket launch. And I encourage you to go learn more about that and learn more about the different parts of weather that could affect it. And when you're trying to build a machine learning model to learn something new, it's really important that you do take that time prior to looking for or manipulating any kind of data, because you do want to make sure that you're gathering the data that's important. So let's think about our technical problem. First, we need to figure out what question we're trying to answer. For that, I love this handy dandy cheat sheet for machine learning algorithms. You can find this and anything else I'm linking to in the Learn module, which is at aka.ms/launch delays with ML-11. This cheat sheet takes the question that you're trying to ask and helps you figure out which algorithm is likely going to be the one that you want to use to build your machine learning model. In this case, for example, I may be asking the question, on this day with these weather conditions, will there be a successful rocket launch? Or could there be a successful rocket launch? It's a yes or no question, given conditions, and likely going to use historical data. As I explore this cheat sheet, I may notice that there is one type of algorithm, namely the two-class classification algorithm, that answers questions like, is this A or B? That could also be replaced with, is this yes or no? So in this case, I think we're probably going to want to use a two-class classification algorithm. We can see here that there are a bunch of different types of algorithms that we could choose from, and we'll get into that when we actually do the live stream and live coding. But since we do want to do a two-class classification, I thought I'd take just a couple of seconds to talk through how machines actually learn. Well, they learn a lot like we do. I'm actually a parent to, she's currently a 3-year-old, and it's very interesting because what I have found is that the way that we teach children about our world is very similar to the way that we train machine learning models about data, aka our world. Let's take a classification type algorithm, for example. One thing that my family loves to do in the springtime is eat berries from outside. Now, we do need to be careful which berries we're eating because some of them are edible and they're great, and some of them you should not be eating. So rather than just gathering only berries that my daughter can eat and having her eat only those, I let her go out into the world, grab some berries, and bring them back. She sorts them, and I say, these ones are berries you can eat, and these ones are berries you cannot eat. We talk about why, And we notice that the berries that we can eat are often red or colorful in some way. So, for example, we have blueberries, we have thimbleberries, and we have huckleberries. So, those are red and blue berries that are really vibrant in color and they're kind of squishy to the touch. However, we also have these snowberries that are white and harder and they're not edible. So as she gathers them, I will help her classify the berries. And we classify in a couple of ways. One is with a name, and the other is with edible or not edible. That's essentially what we do with machines. We send the machines a bunch of data. In this case, we're going to send our machine learning model a row that represents a day, which will have the date and then the weather conditions, and then whether or not a rocket launched on that day. So we provide the data and we provide the classification. We let our machine know this is how you classify this data, and we send it hundreds upon thousands upon millions of rows of data if you can. And the more data that you send and the more interesting or complex that data is, allows your machine to start to really understand what it truly means to have a successful launch day or to have a day that wouldn't be a successful launch day. It's important to recognize where the limitations of your data lie. This is true in both machines. For example, if I were to only be providing data from Florida in the United States, and that was weather data that was collected from the same place in the same way, and then I were to send data from Alaska, it's going to be very confusing to our machine learning model, considering that the weather conditions in Alaska are vastly different than the weather conditions in Florida. So while our machine learning model might learn or determine that anything below this temperature is not a successful day, therefore ruling out all of Alaska, that may not actually be true. The conditions in Alaska might allow for a colder temperature day in order for a successful launch if we were to launch from Alaska. Similarly, my daughter, I feel fairly confident that she can go out into my yard and find berries and know which ones are edible or not. But I wouldn't just send her to another part of the world where there are berries that she hasn't seen before and say, try it out, and have her discover a berry she's never ever seen before, because the variance between berries that are edible and not edible isn't always obvious and isn't always dependent on color or texture or shape or size. So before you go into gathering the data that you want to use to train your machine learning model, you really need to understand what the limitations of your data is, and therefore what the limitations of your model will be. We'll actually talk a little bit more about the limitations of data when we do the actual live stream with the live coding. And I just want to point out that the limitations of data include things like bias, even if the bias is based off of Florida, because that's where the rockets are launching from today. And so that's where we gathered that data. That has bias against other parts of the world because we didn't include other parts of the world in that data. So bias isn't always a negative thing. It's just something that we will always have. And it's important to understand how data was collected, why it was collected, from where it was collected, how it was stored, all of that information in order to determine where the biases are, and therefore determine if that bias will affect the outcome. Well, it always will, but how it will affect the outcome. You don't want to use a machine learning model heavily biased against Alaska to determine the best day to launch from Alaska if you happen to have a space rocket in Alaska. But if you just acknowledge that the model is only for Florida or only for similar climates, then you can know that this model in particular wouldn't be useful there, and that's okay. When you're designing a solution, ideally, you would have a subject matter expert who is co-designing the solution with you. So you might be the data scientist or machine learning expert or developer, and you might have a NASA scientist or weather scientist or even just an organization with their data available to you to be able to draw on and check to see if what you're doing even makes sense. When I first thought about rocket launches and their safety, I was thinking more along the lines of, is there too much pressure or like humidity or rain or wind or things like that? And learning that actually the cloud shape is a really good indicator to those other pieces of information. And it's more the fear of the lightning and therefore the clouds that causes a potential unsafe launch. I realized that the conditions and the clouds are probably the more important pieces of data. However, for this example, I'm not actually working for NASA and designing the actual predictor for rocket launches. I'm just looking to do some exploration. So what I'm going to use is just publicly available data about weather about different places. If I were to extend this project, I might try to see if I can find some, satellite imagery or just like live streams of the clouds in a particular location, and then maybe use image recognition to determine like shapes of clouds or something like that. That could be a lot of fun. But for this one, I just wanted to use an Excel doc of rows of data that are easy to understand, because this was just my first time exploring data related to rocket launches. So that's just a really brief intro into how weather would affect rocket launches and into how you can use data and machine learning to start to explore whether or not rocket launches would be successful given historical and current data on weather. Some interesting open problems. We've already discussed a few, but what happens if we want to launch a rocket from another planet? Let's say we landed on the moon and wanted to launch from there. Does that change? What changes? Can we use anything that we've learned here on Earth out there? These kind of problems are super interesting. I love exploring them. And if you want to continue the conversation with me, make sure to join my live streams every single Tuesday at 3 p.m. Pacific time. Check out some of my other shows at aka.ms/learnwithdrg, and connect with me on Twitter at Dr. Guthels or #LearnWithDrG. Share with me what you're learning, what you're exploring, and what you've discovered. Until then, happy coding, everyone.